Hello students, we continue our lesson about atomic theory with Niels Bohr's atomic theory. We review. The first, you have learned about Dalton, atomic theory, and then J.J. Thomson. Continue with Rutherford, and right now with Niels Bohr. In Bohr model of atom, we have nucleus and then shell represented by N, 1, 2, 3, and so forth. According to Bohr, atom is a small, positively charged nucleus surrounded by orbiting electrons. Bohr was the first to discover that electrons travel in separate orbits around the nucleus, and that the number of electrons in the outer orbit determines the properties of an element. Niels Bohr proposed the Bohr model of atom in 1915. Because the Bohr model is a modification of the earlier Rutherford model, some people call Bohr's model the Rutherford-Bohr model. Now, we will see the main points of the Bohr model. The first, electrons orbit the nucleus in orbit that have a size and energy. The energy of the orbit is related to its size. The lowest energy is the smallest orbit, or the nucleus, the closest to the nucleus. Radiation is absorbed or emitted when an electron moves from one orbit to another. Absorbed when electron moves from the lower to the higher, and radiation emitted when electron moves from the higher energy level to the lower. Now, we emphasize about the energy level. According to Bohr atomic model, a small positively charged nucleus is surrounded by revolving negatively charged electrons in fixed orbit. Here, in this orbit, this is an electron, and then here's the orbit, and this one is the nucleus. He concluded that electron will have more energy if it is located away from the nucleus, whereas the electrons will have less energy if it located near the nucleus. So the postulates of the Bohr atomic model: electrons revolve around the nucleus in a fixed circular path termed orbits or shells, or energy level. The orbits are termed as stationary orbit. Every circular orbit will have a certain amount of fixed energy. Once again, Bohr's atomic model, a small positively charged nucleus is surrounded by revolving negatively charged electrons. The postulates of the Bohr atomic model: electrons revolve around the nucleus in a fixed circular path termed orbits or shells or energy levels. The orbits are termed as stationary orbits. Every circular orbit. The postulates of the Bohr atomic model: electrons revolve around the nucleus in a fixed circular path termed orbits or shells or energy level. The orbits we call as stationary orbit. Every circular orbit will have a certain amount of fixed energy. The electrons will not radiate energy as long as they continue to revolve around the nucleus, or we say in the stationary orbit. We continue. The change in energy occurs when the electrons jump from one energy level to other. In an atom, the electrons move from lower to higher energy level by acquiring the required energy. However, when an electron loses energy, it moves from higher to lower energy level. Therefore, the first orbit or energy level is represented as K shell and it can hold up to 2 electrons. The second orbit or energy level is represented as L shell and it can hold up to 8 electrons. The different energy levels are denoted by integers such as n equals 1, 2, 3, and so on. These are called as quantum numbers. The range of quantum number may vary and begin from the lowest energy level, nucleoside N1, to highest energy level. The different energy levels or orbits are represented in 2 ways such as 1, 2, 3, 4 or K, L, M, N shells. The lowest energy level of the electron is called the ground state. Orbit energy level. The first is K, the second is L shell, the third is M, the fourth is N shell. The third can contain up to 18. The first only 2 electrons. The second 8 electrons, the third 18 electrons. The fourth 32 electrons. Number of electrons. distributed in shells or orbits, the number is 2n to the power of 2 or 2n squared, where n is the number of orbits. The number of electrons K shell, the n quantum number for K shell is 1, so the maximum is 2 times 1 square or 2. Similarly, the number of electrons in L shell, the quantum number n is 2, then the maximum number of electrons is 2 times 2 square, 2 times 4, that is 8. Somehow, there are problems with the Bohr model. The first, it not suits the Heisenberg uncertainty principle because it considers electrons to have both a known radius and orbit. The Bohr model provides an incorrect value for the ground state orbital angular momentum. It makes poor predictions regarding the spectra of larger atoms. So we can say there are limitations of Bohr models. First, Bohr atomic model had few limitation, which is the failure to explain Zeeman effect, or how atomic spectra affected by magnetic fields. The second, it contradicts Heisenberg uncertainty principle. Then the third, unable to explain how to determine the spectra of larger atoms. And here you have solved examples of problem for atomic model. Example 1. Calculate the maximum number of electrons on a shell can hold. We know that we continue with some examples of problem. Example 1. Calculate the maximum number of electrons on O shell. You still remember the formula is 2n squared. O is the fifth shell or orbits. So the maximum number can hold is 2 times 5 squared, or 2 times 25, that is 50. So the maximum number of electrons or shell can hold is 50. There is one other example here. What happens when an electron changes its orbit from outer to inner energy? There are 4 options here. A. Energy remains constant. That is impossible because different energy level absorb here from outer or higher energy to inner or lower. So the energy is not absorbed but released. The answer is D. Finish with Niels Bohr atomic theory. Next we will continue with Erwin Schrödinger, the mechanical quantum theory of atom. See you, students.